Now, our case is that we have learned about factors affecting the strength, and then the causes for the variation of the strength, and then the increment or decrement of the strength of our concrete. Then, how to assess it? Say, for example, if I want to know how much strength is gained in our concrete after particular time, that is to be assessed. Then how it is being done? That is nothing but testing of hardened concrete, we will say. It will be done in two ways. One is such as like measurement of the load bearing of the particular samples of the concrete. Say if I am constructing the house, then I am going to take 3 4 samples of the concrete, and then I am casting it into particular shapes, and then I am testing it by applying the load, and then at which load it is being failed is considered as its strength. That is one manner where I am crushing my sample, and there is the gap in between the concrete what we have placed and then sample what we have taken, because either maybe the discrepancy in the quality, whatever the sample is taken may be like poor, or the whatever the concrete used is maybe the strong. Likewise there might be the discrepancy. Later when the technology have been developed, there were so many improvements have been done, and through that what they have started is that they are doing the test on the concrete what we have placed there itself or at the site itself, and the strength is being assessed with the different methods. So from these things, you will come to know about the two aspects. One is by taking the concrete sample and then crushing it and then finding the strength, one way, and other is just we will go to the site and we will do some tests on the site itself on the structure of the concrete, and then we are measuring the strength. This is another way. So here I am describing these things in a two manners. One is non-destructive test and other is destructive method of testing. Okay, let us see the mechanical mode of testing, such as destructing method or destructive method of testing, where we are crushing the samples or applying the load on the samples and then we are finding the structure what is being subjected to some loading. It will be in three ways. Either it might be a compressive type or flexural type or tensile type of loading will be done. So for these things we will assess the concrete in generally by the compressive testing or tensile testing or the flexural testing. Let us see one by one how the compressive testing or compressive strength of the concrete is being assessed.
The compressive strength of a concrete is defined as the ability of the concrete to withstand specific compressive forces. Compressive strength of concrete depends on many factors such as water-cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Generally, the specimens shaped in cube and cylinder are used for testing the compressive strength of concrete. The standard size of a cubical specimen is 150 mm into 150 mm into 150 mm, while the cylindrical specimen is 150 mm in diameter and 300 mm in length. Generally, the fresh concrete is prepared according to the required grades and the respective mix proportion. Once the fresh concrete is prepared, the inner surface of the mold is greased to avoid sticking of concrete. The prepared fresh concrete is then filled in mold in 4 layers. After filling each layer, tamping should be done for 35 times for cube and 25 times for cylinder using a standard tamping rod. Once the mold is filled, level of the top surface with a trowel. After a day, the mold is removed and the specimens are dropped into the curing tank, at a standard temperature of 27 plus or minus 2 degrees Celsius. After 7 days, the specimen is taken out of curing tank and dried for a while. Then, the specimen is placed on the compression testing machine. The cube specimen is just placed on the bearing plate, while for cylindrical specimen, it is placed vertically. The instrument is adjusted such that the plate touches the top surface of the specimen. The load is applied gradually over the specimen at the rate of 140 kg per centimeter square per minute. The load at which the specimen fails is noted. Thus, the characteristic compressive strength is calculated from the ratio of load and the area. The test is generally done with the help of 3 specimens and tested for 7 days, 14 days and 28 days.
Whatever the load of failure in the dial gauge of the compressive testing machine or CTM is taken, and then it is divided by the area of the concrete cube which was faced the loading. So with that ratio, that is load by area, we can get the stress, and that stress is nothing but compressive stress, because whatever the load we have applied, it is in compressive manner where our concrete structure is being compressed actually in the vertical manner. So it is called as compressive load. From this we can get the idea of the compressive strength of our concrete, that is what we have placed in the structures. In finding the tensile strength of the concrete, there are so many methods where our concrete still even having the lesser capacity to bear the tensile load, but we have to assess it for the load bearing area or capacity. So that we are doing the test in 3 different methods. Generally, one is the split tensile test, and other is double punch test, and then it is ring test. We have the 3 tests, but in common we can say the split tensile test, where the cylinder is made to be broken upon loading, but the loading will be done in the such a manner that it is executing the tensile load, so that we are calculating the tensile strength of our concrete.
In the split tensile strength test, the tensile strength of concrete is obtained by applying a compressive force along the length of the concrete cylinder. The specimen used for this method is of cylindrical in size and dimensions of 150 mm in diameter and 300 mm in length. The instrument used for this method is the universal testing machine. The specimen is prepared in the standard manufacturing procedure and placed on the mold in layers and tamped using 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 7, 14 and 28 days for testing. Draw the line on the specimens as displayed on the screen. Then, record the weight and dimension of the specimen. The specimen is placed longitudinally in the machine. A bearing strip made up of plywood is placed on both sides of the specimen and align it according to the marking. Sometimes, supplement bars are placed on top of the plywood depending upon the diameter of the specimen. Now, apply the load continuously at a rate within the range 1.2 to 2.4 MPa per minute. Finally, note down the load at which cylinder fails by developing cracks. The resultant split tensile strength is calculated by the equation 2P divided by Phi into D into L. where P is equal to load at which the specimen breaks.
Flexural strength of the concrete will be tested by using the flexural testing, where a beam is being formed without any reinforcement, and that beam is subjected to the loadings. It might be a double loading, double point loading, or 3 point loading. So that we are going to do the tests, and then upon the failure, we are going to note down the load, and then we are getting the value.
The test is made on the beam of size 150 mm into 150 mm into 700 mm or 100 mm into 100 mm into 500 mm. Flexural strength of concrete is determined by either central point loading or two-point loading. The typical machine used for this test is shown on the screen. The bed of the testing machine is provided with two steel rollers of 38 mm in diameter. The rollers is mounted at the distance from center to center is 600 mm for 150 mm specimens and 400 mm for 100 mm specimens. The load applied through similar roller mounted at the top. In case of two-point loading, the rollers are spaced at 200 cm or 133 cm center to center. The concrete is prepared as per required grade of concrete and placed on the mold in layers and tamped 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 14 and 28 days for testing. The specimen is placed on the rollers and centered with the longitudinal axis of the specimen. The load is applied at a rate of loading of 400 kg per minute for the 150 mm specimens and at a rate of 180 kg per minute for the 100 mm specimens. Finally, note down the load at which cylinder fails by developing cracks. Now, measure the distance between the line of fracture and the nearest support. Consider this as A. If A is greater than 200 mm for 150 mm and 130 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation. Fb is equal to P into L divided by Bd square. If A is less than 200 mm and greater than 170 mm for 150 mm and less than 133 mm and greater than 110 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation. Fb is equal to 3Pa divided by Bd square, where B is the width of the beam in millimeters, D is the failure point depth in millimeters, L is the supported length in millimeters, P is the maximum load applied to the beam in kilograms, and A is the distance between the line of fracture and nearest support in millimeter.
So these three are the different kinds of tests we have by the destruction of the sample what we have. But as I said in the beginning, there is a lack in between what the concrete we have placed and what the concrete we have taken, and the method of compaction what impacted over there, what the method of compaction impacted in the sample. there might be the lag because it is not going to exactly 100% similarity, but there will be the like a similarity about 90 to 95% of similarity. So we have agreed with that and then we are running with that, but we are not satisfied. So what we are doing is, let us see the concrete what we have placed at the site, whether it is having the same strength, or some of the cases we may compare with the CT test, that is compressive testing strength, and then the in situ test, so that value is being taken for the assessment by both of these methods. Then what is those methods, what are all those methods we have for the assessment of the concrete at the site? Those are all called as the non-destructive tests. As the name it is saying, we are not at all doing any load on the concrete structure so that it is going to fail or crush. So it is not going to cause us any loss. So in that, we are just doing the strength on the concrete at the site itself using so many methods. In that, few methods are like rebound hammer method is there, that is Pandit experiment will be done, or we have the ultrasonic pulse velocity method, that is UPV testing method we have, or ultrasonic wave method or resonance method we have. Likewise, we have the different methods. Using these methods, we can assess the durability of the concrete, the strength of the concrete what we have placed, and even the cracks or even the empty pockets what we have formed after hardening of the concrete. And even we can assess the complete structure of the concrete what we have placed, whether it is going to have the load bearing capacity of our required extent or not. These many things can be assessed directly using these non-destructive tests, and you will learn about these next videos in the regarding the non-destructive testing methods in detail. Now we have the idea how we are going to assess the strength of the concrete in different manners, such as destructive ways and non-destructive ways.
Non-destructive testing, NDT, is defined as the method of inspecting, testing, or evaluating materials, components or assemblies without destroying the serviceability of the part or system. Non-destructive testing is considered as a powerful method for evaluating existing concrete structures in terms of their strength and durability, and also helps in assessing and controlling of quality of hardened concrete. NDT also helps in investigating about the crack depth, micro cracks, and progressive deterioration. NDT methods do not affect the future usefulness of a structure. These methods are used to measure properties of concrete such as hardness, resistance to penetration of projectiles, resonant frequency, and ability to allow ultrasonic pulse velocity to propagate through it. With the help of these data, the strength, durability, and other required properties of concrete are calculated. There is a wide range of NDT methods which are used by the civil and structural engineering industry. The most common methods of non-destructive testing of concrete are surface hardness methods, penetration resistance method, pull-out resistance methods, pull-off resistance method, resonant frequency test method, maturity test method, permeation test method, ultrasonic pulse velocity method.